y is greater than 5/3 x minus 2. So I first know this is a dashed line because it says greater than. So I'm going to graph this the same way I would graph y equals 5/3 x minus 2. I start at the -2, and I go up 5 and over 3 throughout my graph. Up 5 and over 3. I'm going to break out my ruler. I'm going to line up my points. This is going to be a dashed line because it just says greater than. Zero, 0 does not fall on my line, so I'm going to use it to decide which side of the graph I shade. So is 0 greater than 5/3 times 0 minus 2? Is 0 greater than -2? Yes, it is. So I shade the region of the graph that contains 0, 0. So that would be everything on this side of my graph. I'm going to do the same thing with my second equation. So I'm going to graph this the same way. I'm going to graph y equals 1/3 x plus 2. This is a solid line because this says less than or equal. I'm going to start at the 2. I'm going to go up 1 and over 3 throughout my graph. I'm going to break out my ruler. This is going to be a solid line because this says it is less than or equal to. Now I'm going to choose to shade this the same way I did the other. 0, 0 is not located on that line, so I'm going to plug it in. Is 0 less than or equal to 1/3 times 0 plus 2? Is 0 less than or equal to 2? Yes, it is. So I shade the region of the graph that contains 0, 0. So I'm going to use a different color. I'm going to use red. And so that would be everything below the line. So if you notice, the section of the graph that contains both the blue and the red would be considered the solution to this inequality, or this system of inequalities, because this is the only region of the graph that works for both.